All right, welcome to the Chapter 8 practice test. I'm Mr. Quatrin. I'm here to guide you through. Before we start, make sure that you have all of your tools. Make sure you have a pencil. I have an erasable pen since pencil doesn't show up very well on the video. I've also got my calculator. So let's begin. So first off, always put your name. I am Mr. Q. So, number one, list as many characteristics of arithmetic sequences as you can. This is more of a review idea thing. This mostly wants you to say what you know. So, arithmetic sequences grow by adding and subtracting. When you make the equation and simplify it a certain way, it looks linear. If it looks linear, then your first differences are constant. And because we are adding or subtracting, there is a common difference, which we call D for difference. And geometric, on the other hand, grow by multiplication. Remember, division looks like multiplication, but when you are dividing, you're actually multiplying by either fractions or decimals, and we need to make sure that we actually keep the fraction decimal version of that for all of our geometric formulas. So don't say that you're dividing by r, say that you're multiplying by an r that's a decimal or a fraction. When we look at the sequence, if we try to graph it, it looks exponential. And again, because we're growing by multiplication instead of a common difference, we have a common ratio, which we call R for ratio. So, number 3. Is this sequence arithmetic, geometric, or neither? Well, if I go from 11 to 19, it looks like I'm adding 8. 19 to 27 is plus 8. 27 to 35 is plus 8. 35 to 43 is also plus 8. 43 to 51 is also plus 8. You have to check all of them, because remember, if any one of these is different, it's not actually arithmetic. But because we are just adding and we're always adding the same number, this is an arithmetic sequence. And that means that we have a common difference, not a common ratio, and our common difference was 8. That's the number that we're adding every time. So the recursive rule, whenever you have a recursive rule, the only number you actually need to plug into the formula is either D or R, because everything is defined by the next number is the last number changed slightly either by adding or by multiplying. So all we need for the recursive rule is D, which we have, so A sub n equals A sub n minus 1 plus 8. The explicit rule, on the other hand, you need both a D and your first term in the sequence. You need A sub 1. Those are the only two things you need to plug in. So A sub n equals the first number in the sequence. So A sub 1 is our 11 here that started us off, plus 8 times n minus 1. I'm okay with that. Check with your teacher about how they want you to leave this. If you want, in my class, you are allowed to distribute the 8 and combine your like terms to get 8n plus 3, but I'm okay with just leaving it as 11 plus 8 times n minus 1. Now, a sub 15 means that we're going to plug in 15 for n. So a sub 15 has to equal 11 plus 8 times 15 minus 1. Excuse me. And that sounds like a calculator problem at this point. 11 plus 8 times 15 minus 1. Yeah, I know I can do 14 in my head, but that becomes 123. That's number 3. Number 4, we have negative 486 positive 162, negative 54, positive 18, negative 6, and positive 2. So it looks like to get from negative 6 to positive 2, we divide by negative 3. But remember, we don't want to divide. We want to either multiply by negative 1/3 or negative 0.333. And if we work backwards, 18 to negative 6, that's also times negative 1/3. Negative 54 to 160, or 162 to negative 154, that's also times negative 1/3. 54 to 18 is also times negative 1/3. 486 to 162 is also times negative 1/3. So this is all growing by multiplication, even though you might think it's division. So that makes it a geometric sequence. This one then has a common ratio, and that common ratio is negative 1/3. Our recursive rule then is a sub n equals a sub n minus 1 times negative 1/3. And again, our first term in the sequence was negative 486, so a sub 1 is really negative 486. So a sub n has to equal negative 486 times negative 1/3 to the n minus 1 power. And then to find a sub 11, you might want to use your calculator again, but remember with fractions and with any addition or subtraction within an exponent, you need to be careful about where you put your parentheses. So if I try to find a sub 11, we have negative 486 times negative 1/3, 1 divided by 3, and that is raised to the power of, parentheses, 11 minus 1, which gets us negative 0.008 if you would leave that in the decimal form, but if you hit math 1 on your calculator, we find that that's actually negative 2/243. And that's number 4. Number 5, 3 to 6, that looks like a times 2. 6 to 12 is a times 2. 12 to 24 is also times 2, and times 2. So that's again geometric. And that means that we have a common ratio of 2. That means our recursive rule is that a sub n equals a sub n minus 1 times 2. Our first term, a sub 1, was 3. So a sub n equals 3 plus 2 times n minus 1. Or if you distribute, we get 2n. Let's see here. Negative 2 plus 3 would be 2n. And this is why we have the erasable pen, just in case my handwriting is not great. So 2n, and then negative 2 plus 3 is positive 1. And then a sub 15, again, n is 15, so 3 plus 2 times 15 minus 1. Is 31. So a sub 15 is 31. And that is your first page. So next up, 6 and 7. Find a rule to find the nth term for an arithmetic sequence, given the two terms. So they gave us a sub 3 and a sub 12. They didn't give us d. They didn't give us a sub 1. So we need to figure out a way to find our common difference first, and then we'll use that to solve for a sub 1. So I'm going to do some u substitution. I'm going to create a dummy variable called u. It's just so that I remember that I'm not actually working in a anymore. And I'm going to subtract 2 from each of these n numbers to turn my a sub 3 into a u sub 1. U sub 1 is still 22. And because I subtracted 2 from my a sub 3 to make it into a u sub 1, I also need to subtract 2 from my a sub 12 to make it u sub 10, equals negative 23. So, again, it's arithmetic. So if u sub n equals u sub 1 plus d times n minus 1, then I'm going to use the 10 as the bigger number. So negative 23 equals 22 plus d times 10 minus 1. If we subtract 22 from both sides, we get negative 45 equals 10 minus 1 is 9d. And if we divide by 9, then we find that our common difference is negative 5. So the recursive rule then is that a sub n equals a sub n minus 1 minus 5. We could say plus a negative 5, but minus 5 is the most efficient way of writing that. So for the explicit, the only part that we actually need is the a sub 1, because a sub n equals a sub 1 plus d, but again, plus a negative 5. We can write more efficiently by saying minus 5 times n minus 1. So if we plug our a sub 3, 3 for n, 22 for a sub n, into that, 22 equals a sub 1 minus 5 times 3 minus 1, or 22 equals a sub 1 minus 10, which means that 32 is our starting term. So our full equation is a sub n equals 32 minus 5 times n minus 1, or negative 5n. Negative 5 times negative 1 is positive 5. Positive 5 plus 32 is plus 37. Number 7 is a little bit nicer. They actually gave us the r, so our recursive rule is that a sub n, and again, because it's an r, that means it's geometric. So a sub n has to equal a sub n minus 1 times r, and my r this time is 1/4. I'm not going to say 0.25 this time because they gave us the 1/4. If they gave us the 1/4, that means they probably want us to work, or at least give our final answer in fractions. You can work in the middle in decimals if you like, but make sure your final answer is a fraction. So now we just need to find a sub 1 again, because a sub n for geometrics equals a sub 1 times r to the n minus 1 power. So if we use 6 as n and a sub 6 as 2, then 2 equals a sub 1 times 1/4 to the 6 minus 1 power. 1/4 to the 6 minus 1 power is a little bit like saying that 2 equals a sub 1 times 1 over 4 to the 5th power. 4 to the 5th power is 1024. So that's 1 over 1024. And if I multiply both sides of this equation by 1024, then 2 times 1024 is 2048 for our starting term. So again, I didn't give myself enough space here, but that's okay. That's why we have erasers. So 2048 times 1/4 to the n minus 1 power. So for 8 and 9, which term is the given number in the indicated sequence? So a sub n is 2500 in the sequence where a sub 1 is 4 over 25, and r, so it's geometric, is 5. So again, we know that a sub n equals a sub 1 times r to the n minus 1 power. So 2500 has to equal 4 over 25 times 5 to the n minus 1 power. So I'm going to multiply both sides of this equation by 25 over 4 to clear out that fraction. So 2500 times parentheses 25 over 4 is 15,625. 15625 equals 5 to the n minus 1 power. From there, we have to take the logarithm of both sides. So the log of 15625 is going to equal the log of 5 to the n minus 1 power. But then, again, the whole point of taking the log is that we are allowed to take the exponent out. So n minus 1 times the log of 5. And I might do the next problem on a separate piece of paper just so we can read all of it. If we divide both sides by the log of 5, then we get the log of 15625, close parentheses, divided by the log of 5 is 6, equals n minus 1. So if n minus 1 is 6, then n is 7. Number 9, here, maybe I won't. Number 9 is a sub 1 equals negative 13 and d equals 11, but that's the bell for the first class, so I'm going to pause here and then come up soon with the next part of this video. So welcome back to part 2. This is in the middle of, or at the beginning of second period, so we're going to make sure that everybody gets through all of this. Okay, so number 9, a sub n equals 75 in the sequence where a sub 1 equals negative 13 and d is 11. Here, let me zoom in a little bit here, make it a little bit less terrible to read. So if we have a common difference, does that make us arithmetic or geometric? Arithmetic. So D means that we are working with the arithmetic. So A sub n has to equal A sub 1 plus D times n minus 1. And they told us that A sub n is 75 equals A sub 1 is negative 13 plus 11 times n minus 1. We have a few options here. I'm going to start by adding 13 to both sides. 75 plus 13 is 88 equals 11 times n minus 1. When we divide by 11, we get that 8 equals n minus 1, and that means that n must be 9. All right, and that was number 9. Okay, find the missing terms. When you're finding the missing terms, the arithmetic sequence goes negative 2, blank, 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 52. So that's A1, A2, A3, A4, A5, A6, and A7. We need to find our common difference because, again, arithmetic. So we know that A sub n, or A sub 7, is 52. And that equals A sub 1, or negative 2, plus D times the n was 7 minus 1. So 52 plus 2 would be 54. Equals 7 minus 1 is 6D. And 54 divided by 6, turns out our common difference is 9. So if we take our negative 2 and add 9 a few times, we get the next few numbers. So negative 2 plus 9 is 7, then 16, then 25, then 34, and the next one would be 43. And then we'll just check the last one. Yes, we do actually get to 52. All right, so that is number 10. Okay, make sure I got everybody who came in. Yes, I did this time. For a geometric sequence, we have a common ratio. So again, we have A1, A2, A3, 4, 5, and this time we end on A sub 6. So 3072 has to equal A sub 1, or 3, times r to the 6 minus 1 power. If I take 3072 and divide that by 3, I get 1024 equals r to the 5th power. To get rid of the 5th power, we need to take a 5th root of 1024. And so that would be 5 math 5 of 1024, which is 4. So if we're going to multiply each of these by 4, we start with a 3 times 4. And there we go. Our numbers are 12, 48, 192, and 786. Okay. So I am kind of keeping this a little bit more focused up here for myself. Again, please feel free to follow along. I know I'm going to go a little bit quickly. If you have any questions, slow me down. So again, next one, geometric. They give us 96 something, 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 and then 3/8. So that means that they must want us to end with a fraction. So they gave us A sub 1, but not A2, 3, or 4. But they did give us A sub 5. And again, they said it's geometric. So A sub 5 would be 3/8 equals A sub 1, 96, times r to the 5 minus 1 power. If I take 3/8 and divide that by 96, we get a weird looking decimal, but math 1 tells us that's actually 1 over 256. equals r to the r to the fourth power. And again, when you're taking the root of a fraction, you're just kind of taking the fourth root of the top separately from the fourth root of the bottom. So 4 math 5 of just the 256 part is 4 for the bottom of our fraction, so our common ratio is 1/4. Again, multiplying by a fourth is a lot like dividing by 4. So we can start up with our 96 and then divide by 4 a few times, and we get 24, 6, and then the last one is 1.5. 1.5 won't work, though, because they gave us fractions. So math, 1.5 is really 3 over 2. And there we go. So if we have neither an arithmetic nor a geometric, do you guys remember which type of function we often ask about? It's almost always going to be a quadratic. So they gave us a 1, a 2, a 3, but not a 4 or a 5. They did give us a 6. So stat edit in the calculator. Clear out my lists here. So the numbers I actually have are 1, 2, 3, and 6 for my inputs. And then my outputs were 3, 6, 15, and 366. So stat calc will do a quadratic regression on that using L1 as my x values or my n values. L2 is my output values. And that... L1, the n values. So the sub numbers, 1, 2, 3, and 6. And that's a weird set of numbers, but that's okay. Y equals 21.298 n squared minus 77.602 n plus 64.077. And we just need to plug in 4 and 5 into that. So 21.298 times 4 squared minus 77 point... Hey, guys, music off, please. 602 times 4 plus 64.077. Make sure I've only got 1 point in there. And we get that a sub 4 should be about 94.437. And then we'll go back, plug in the 5s. She gets something like 208.517. And then just to be sure, I'll go back, plug in my 6s, and see if I actually get something close to 366. And that's close enough based on the rounding that I did. From there, you go into Stat and then the Calc menu, and you want to run a quadratic regression. I might come back and look at this problem again later. I assumed it was quadratic, but now I probably should have done my common differences where I added 4 and then I added 9, and so in between I would have to add 5, but I'm not sure if that was actually an issue here. Page 3. Write these in summation sigma notation. So -4 plus 2 plus 6 plus 8 plus 20 plus... Okay, so it looks like I am adding 6 between every step. So my common difference is 6. My starting term is -4. So the sum of term 1 up to 1, 2, 3, 4, 5, 6, 7, 8 of... -4 plus 6 times n minus 1. 1350, 450, 150, 50. It looks like we are multiplying by 1/3 each step here. So that means our common ratio is 1/3. and our starting term is 1350. So the sum of everything from 1 to 4 is going to be based on the rule 1,350 times 1/3 to the n minus 1 power. So for 16 through 18, they actually want us to find all of the sums there. And so the series, we could plug in every number between 2 and 11 into 3n minus 1 and then see what we get. Question? A sub 1 equals -4 because the first number in the sequence was -4. Yep. 3n minus 1, that looks linear. If it looks linear, that means we have an arithmetic sequence. So the sum is actually going to go from... maybe I do actually have to plug in all the numbers, because if I start on a 2, S sub n actually means start on 1 and keep going. So let's actually just do this really quickly. Here, in the calculator, stat edit. My numbers are 2 through 11. And my L2 rule, clear that out. And that's going to be everything in L1 times 3, so 3L1 minus 1. And boom, there we go. So the numbers are 5, 8, 11, 14, 17, 20, and 23, and 26, 29, 32. So you can use your calculator to get through that pretty quickly. (26, 29, 32). Okay. And when we add all of those together, we get 185. Start at 2 for L1 because they gave us the 2 at the bottom of the sigma. Yeah. For the S series rule, the S sub n means we have to start with term 1. The first L2 numbers, so the way that I got my L2 numbers, stat edit, when I clear this out, I can define L2 as, if the rule is 3n minus 1, and n is everything in L1, I just went 3, second 1, so 3 times L1, minus 1. And then when you hit enter, it automatically plugs in all of those L1 numbers. I probably could have made a shortcut through that by reducing the 2 to a 1, reducing the 11 to a 10, and then just calling the 5 or the 8 my first term, but might be a little bit easier just to get the numbers and add them. So for geometric series, because this one has multiplication, it looks like an exponential. S sub 9, the sum of the first 9 terms, is going to have to equal A sub 1. A sub 1 then, if I plug in 1 there, that would be 3 times 1 minus r to the n, 1 minus 2 to the 9th power, over 1 minus r. So, plugging that into the calculator, 3 times, parentheses, 1 minus 2 to the power of 9, close my top parentheses, divided by new parentheses, 1 minus 2, close my parentheses twice, and we get that the sum should be about 1,533. It's because the formula is 1 minus r. Yes, yeah, you have those formulas on the note card, and actually they are on the front of this sheet here. Yeah. All right. So, write an explicit rule for the sequence. Given that, you've got a recursive rule and your starting term. So, If a sub n equals a sub n minus 1 plus d, that means that d is 13, and they gave us a sub 1 is negative 12, so a sub n equals negative 12 plus 13 times n minus 1. If you want to simplify that further, you can make that into 13n. 13 times negative 1 is negative 13, minus another 12 would be negative 25. Again, check with your teacher about what they want you to leave it as. Write a recursive rule for the sequence given the following. So they gave us the explicit rule. That means that our common ratio is 3. So the recursive is that a sub n equals the one before it, a sub n minus 1, times 3. And that's it. Questions before I keep going? Cool. You will probably have to do a quadratic regression in the test. So you might want to put that in your note card. Just the one in the neither category that we looked at. Just number 13. Yep. Other questions? Yep. Okay. Cool. Nope, no bad. Or, yeah, no bad. Works for me. All right, number 20. Given the following piece of information about a sequence, write down as many other things that you know about the sequence. I know that this looks linear. So what is it? So it's arithmetic. We can also figure out what is a sub 1. What's my starting term? It's going to be 11 because we start up here. And then what does it look like our slope is? It looks like we are falling 2 and running 3, so that means that our common difference is falling 2 and running 3. Common difference in the arithmetic sequences is the same idea as your slope. And now we're on to page 4. Okay, so my photocopy didn't quite work out here, and this is another quadratic. So write an explicit rule to describe the total number of squares in each figure. So it looks like in figure 1, we had 1, 2, 3, 4, 5. Figure 2, we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Figure 3, we had 1, 2, 3, 4, 5, 6, 7, 8. Well, no. Yeah, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So to get from 5 to 10, we have to add 5. To 10 to 17, we have to add 7. And it looks like in between we're adding 2. It's not linear. It's not geometric. It's not linear, so it's not arithmetic. It's not exponential, so it's not geometric. Therefore, it must be one of those quadratics that I told you would be the third option. So we're going to run a quadratic regression on this. We're going to clear out the lists again. So if I'm just looking at 1, 2, 3, and my other numbers are 5, 10, and 17, stat calc quadratic regression on L1, L2, we get that y equals, or a sub n equals, 1n squared plus 2n plus 2. And r squared equals 1 here. If you don't have that turned on, that's okay. But I do have it turned on. That means that's 100% accurate. Yeah. Then how many total squares are in figure 8? So a sub 8 has to equal 8 squared plus 2 times 8 plus 2. So 64 plus 16 plus 2 is 82. And our final question. You are hammering a nail into a board. That board is 100 millimeters thick. The first time you hit the nail, it moves 20 millimeters into the board. The next time it moves 18, and the third time you hit it moves 16 millimeters more. Assuming this pattern continues, what type of sequence is this? So we went from n to a sub n. At 1, we went 20. For number 2, we only went 18. For number 3, we only went 16. And it looks like we are subtracting 2 millimeters every time, so it must be arithmetic. So the 15th hit, well, we should probably figure out what the equation is. Again, a sub 1 was 20. Our d, our common difference, is negative 2. So a sub 15 equals 20 minus 2 times 15 minus 1. And again, that sounds like a calculator problem now. 20 minus 2 times 15 minus 1 is negative 8, which sounds like you just pounded it through the end. That's a little weird. It sounds like you are losing inches every time. And so by the time the 15th hit, you are kind of just pounding the wood. Yeah. It won't really move any farther through the wood at that point. So we definitely got through the nail. We got the nail through long enough that we're actually not going to be making a lot of progress as we keep hammering. So will 8 hits be enough to completely get through the board? So let's find out. We want to find the sum of the first 8 hits. And again, it's arithmetic. So S sub n equals n over 2 times a sub 1. A sub 1 was 20 plus a sub 8. So I need to find a sub 8 really quick. On the 8th hit, we are looking at 20 minus 2 times 8 minus 1. Yeah. So we are hitting 6 inches on the 8th, or 6 millimeters. So 8 halves is 4. 20 plus 6 is 26. 4 times 26 is 104 millimeters, which means that we're actually all the way through the board. And actually, remember, if you want a nail to be effective, it needs to go all the way through the board and into the next board so that it actually holds the 2 boards together. So the final answer is yes, 8 is enough. And that is the second part of our review video. All right, welcome back. So number 13, I actually messed up a bunch. So again, this is why we bring erasers or erasable pens or pencils or whatever. You might notice that my answers, 94 point something and 208 point something, are not the answers in the answer key. So let's go back. So the way that I ultimately solved this was just through guess and check. One, two, three. We're looking for number 4 and number 5, and we have number 6. So last time I just kind of assumed that this was a quadratic. If we go from 3 to 6, that is adding 3. 6 to 15 is adding 9. Yep. And then between those, I would have to add 6. If I just go with that pattern, it's not quite going to work. Also, this pattern is, personally, I need a little bit more before I can actually see what the pattern is. Turns out, stat edit, putting these numbers back into the calculator. So remember, I've got my diagnostic turned on. If you want to do that, you hit second 0, go to the catalog, and you want to find D for diagnostic. The fastest way to do that is to hit alpha D. and then go for diagnostic on. The diagnostic on, done, will turn on that R thing for you. So again, I tried the quadratic regression on my L1 and my L2, and the R squared thing here says that I am 99.76% accurate, which is not 100%. But if I go back to StatCalc and try a cubic regression using L1 and L2, then I am 100% accurate. So the actual equation is that a sub n equals 4.8 n to the third power minus 25.8 n squared plus 46.8 n minus 22.8. Let me scroll that up a little bit so you can see that. And then we need to find out the fourth and the fifth terms. So 4.8 times 4 to the third power minus 25.8 times 4 squared plus 46.8 times 4 minus 22.8 is 58.8. Wait a minute. Well, that's not right. If I try it with the sixes, then I get 366. So my numbers should be 58.8 and 166.2. Sorry about that. I will add that in as soon as I can.